Hello friends, I welcome you on BYJU'S Exam Prep, the most comprehensive preparation app for all exams. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio and visual quality, everything is clear. Till the time you are going to report this, let me just brief you what is going to be the ideal duration and the agenda of the session. My friend, the ideal duration of the session is going to be approximately 45 minutes. And the agenda or the outcome of the session is that today we are going to talk about some of the important questions related to your subject electromagnetic field theory, where we are going to discuss magnetic field and potential. So everybody who is joining me, just quickly hit the like button and share and subscribe the session so that more and more people are going to join us, so that everybody can be benefited. So just once in the comment section, tell me whether my audio, visual quality, everything is clear, everybody. Yes, everyone. Yes, everybody hit the like button, share this session with your friends and colleagues, and let us start with the session. As some of you may be joining me for the first time, so there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 10 plus years of teaching experience, completed MTech from IIT BHU in 2010. I have written a couple of books. One book, Engineering Ethics, is already in the market, and one book I have written on power system, which is yet to hit the market. My areas of expertise are power system, electrical machines, electromagnetic field theory, material science, and obviously engineering ethics. Let us start with the first question. The question says, a steady current I flows through a long cylindrical wire of radius r. Find the magnetic vector potential at any point outside the conductor at the radius. Vector potential on the surface of the conductor may be taken to be equal to 0. See, the situation is something like this. Suppose this is going to be the long cylindrical wire. At any radial distance, suppose r, you want to find the value of the magnetic vector potential A. Now, because of this infinite wire, we can divide this infinite wire. Hello Ankit, how are you? Welcome to the session. We can divide this infinite wire in two sections like this. This is going to be a small element of length dx, and suppose this distance is going to be x, and suppose this angle is theta. How we are writing the magnetic vector potential from the infinite line? You can write it as dA is equal to mu naught I upon 4 pi, and this is going to be dl divided by this distance r square plus x square. So this is going to be r square plus x square, and this distance dl is going to be dx, something like this. And if you want the total magnetic vector potential, then you have to integrate it mu naught I upon 4 pi, this is going to be I dx upon under root r square plus x square. So can you integrate this? Everybody tell me in the comment section. Yes, everyone. You have to use a little bit of trigonometry to get the final result. Yes, everyone. Can you do this? Should I write the final expression after this? Can you do it? You know the trick how you have to do it. You have to put x is equal to r tan theta, and accordingly you have to follow this integration. I am telling you the final expression that you are getting. Please cross check it. This is going to be mu naught I upon 2 pi, as per my reference, and this is going to be ln. This is going to be 2 L upon R. This is going to be your final statement. One approximation you have to use here, that is the length L is going to be very, very large in comparison to the radial distance of the point where you are finding the magnetic vector potential. Is it clear for everybody? See the next question. He is saying the energy is stored in the magnetic field of a solenoid 30 centimeter long, 3 centimeter diameter, wound with 1000 tons of wire carrying a current of 10 ampere. You know the energy stored can be written as half L I square. Now I here is given as 10 ampere. How you are going to find the L value? You know that L can be defined as the total flux divided by the current because of which you are having this flux. Now this total flux you can write as N as the number of turns of the coil, and if phi is the flux passing through per turn, and this phi you can write as B dot A. Now this B you can write as mu naught H, and this is going to be A, and H you can write by using the Ampere's circuital law, H dot dl is equal to Ni. So if H is going to be same at all the point and L is the mean core length, then you can write directly from here H as Ni upon L. Just put this value here. It is going to be mu naught N, and H is going to be Ni upon L, and this is going to be the cross section area of the coil. Just put this value here, so you will be getting the standard formula mu naught N square A upon L, because the current is going to be cancelled. Yes everyone, tell me in the comment section, are you able to follow this? Now you can put the values here. Number of turns, you know the number of turns are given as 1000, N is given as 1000, cross sectional area is given as okay 3 centimeter is the diameter is given, so cross sectional area you are going to write as the length of this solenoid is going to be 30 centimeter, 30 into 10 to the power minus 2, and the cross sectional area is going to be pi r square. So r I am writing as d by 2 because diameter is given, and you have to put this diameter as 3 centimeters. 3 into 10 to the power minus 2 meters. Everybody tell me in the comment section, can you do this now? So if you put these values, you must be getting the final answer as 0.15 joules. 0.15 joules is going to be the energy stored in the coil. Is it clear for everybody? Yes, tell me in the comment section. Ankit, are you able to follow this? Is it clear for everybody? Let us see the next question. Next question, he is saying there is an infinitely long straight wire which carries 1000 ampere current. In the vicinity there is a circular conducting loop of 100 millimeter diameter with the center of the loop 1 meter away from the straight conductor. So the situation is something like this. This is going to be your straight wire, and there is going to be a conducting loop whose center is going to be at a distance of 1 meter He's saying both the wire and the loop are coplanar. It means they are in the same plane. He's asking determine the magnitude and the direction of current in the loop so that it produces a zero flux density at its center. Now if you observe what is happening, if the current in the wire is in this direction, if you apply the right hand thumb rule, suppose this is current I1, then the magnetic field because of this current in the wire is going to be into the plane. So this is going to be H1 into the plane at the center of the loop. If this loop is going to have such a current so that magnetic flux intensity is coming out of the plane, then it can cancel out this intensity and you can have zero magnetic field intensity at the center of the loop. This is the logic you have to apply. Again, if you apply the right hand thumb rule, the right hand thumb placing outwards, the current direction you will be getting as anti-clockwise. And suppose the magnetic field because of this current I2 in the loop is going to be H2, which is coming out of the plane. So basically you have to write the magnetic fields H1 plus H2 as 0, but because you know they are in the opposite direction, so if you put the sign, so directly you can write H1 is equal to H2 in terms of the magnitude. What is going to be H1? H1 from infinite long wire you can directly write as mu naught I upon 2 pi. Suppose this distance is going to be let me take it as small r. This is going to be small r, and the magnetic field intensity because of the loop is going to be mu naught I upon 2 capital R. Suppose the radius of the loop is going to be capital R. Is it clear for everybody? Hi Juhi, how are you? Welcome to the session. Definitely whenever the verbal classes are going to be planned, you will be informed and you can attend those classes. Okay. See, if you see basically the important topics in MFT you understand both for electrical and electronics, the common area is electrostatic and magnetostatic. So that is going to be important for both of them. But if you see for electronics people, transmission line, waveguide, antenna, that is also going to be important topics. Okay. And if you see the previous year trend, the number of questions which is being asked from this area is increasing. So just put in this equation, H1 is equal to H2, this is going to be I1, this is going to be I2, this is going to be mu naught I1 upon 2 pi small r is equal to mu naught I2 upon 2 capital R. If you solve this, mu naught is going to be cancelled, 2 is going to be cancelled, and you can write I2 as capital R I1 upon pi r, where this small r is 1, capital R, the radius of the loop is mentioned, the diameter is given as 100 millimeter. So what is going to be the radius of the loop? It is going to be 100 10 to the power minus 3 divided by 2. So you have to use this value for capital R. I1 is also given. I1 is given as 1000 ampere. So you can find what is the value of current I2. Yes, everybody just solve it and tell me what is the answer you are getting. I think you must be getting as 15.92 amperes. Everybody just tell me in the comment section. Ju is asking what is the difference between potential and field. Listen carefully. If you talk about field, field represents the strength of the field in terms of source or in terms of force, that is effect. For example, if you have two regions, this is region 1 and this is region 2. Suppose region 1 there is no field and there is region 2 which is going to have field, then how you identify whether there is a field or not? Field is like a force in waiting. If there is a particle in this region where there is no field, no force is going to be experienced by this particle, but the moment it comes and enter into this region where there is a field, we don't know what type of force, but definitely some force is going to be there on this particle because of the presence of the field. So you understand the field in terms of the strength of the field, in terms of the force or the effect it is going to create. Is it clear? Is it clear, Juhi? And if you talk about potential, potential gives you the ability of the system, that how much energy it can store. You understand that we relate potential with the energy. So you understand it is the capacity of the medium or the region where the field is present, how much energy it can store. See, if you have any problem in these basic doubts, then first you have to cover the theory part. That is going to be important for you, because in these type of sessions we have to take care of number of questions, otherwise it is going to be left. Now see this. This question is giving you the magnetic vector potential as A is equal to e raised to the power minus y sine x az. Yes, and he is saying there is an infinitely long conductor having the cross section area. Cross section area is given as 5 mm square, that you can write as 5 10 to the power minus 3, or it is going to be minus 6 because it is mm square, and carrying a DC current I, which is given as 5 ampere in the y direction. So you can write the current as, or current element as I dy. Okay, this is going to be 5 dy in the direction ay. He is saying determine the expression for the magnetic field density and the force density. So the first thing we are going to find is B. How you can relate B? B you can write as the curl of magnetic vector potential. So this you can write as Ax, Ay, Az. This is del upon del x, del upon del y, del upon del z. And this A component is only present for the z direction, so these two components are going to be 0, and the z direction component is going to be e raised to the power minus y, and this is going to be sine x. Is it clear, everybody? Are you getting that? This is the equation you have to use to find the magnetic field density from the magnetic vector potential given. If you solve this equation, just do along with me. I am giving you the final expression for the magnetic field density. You must be getting B as per my reference, it is coming out as e raised to the power minus y sine x, and this is going to be Ax, just confirm this value, minus, this is going to be e raised to the power minus y, and this is going to be cos x, and the direction is going to be ay. Now he is asking the force density. So in order to find, the next part is to find the force density. In order to find the force density, what I will do? First I will find the force. How you are going to write the force? Force is going to be ideal cross B. Yes or no? Ideal cross B, and you have to integrate it. Ideal is going to be I dy, and this is going to be ay, and you have to take the cross product, and B is given as minus e raised to the power minus y. This is going to be sin x ax minus e raised to the power minus y cos of x, and this is ay. And the integration is going to be for the infinite long wire. So this length y you have to take along the length of the wire, so it is going to be from 0 to infinity, because the complete infinite wire you have to take care. Yes. Now if you see, because this current element is in the y direction, so with this factor, that is the y direction factor, it is not going to give you any product, because cross product for the same unit vectors is going to be 0. But if you take the cross between ay and ax, then you will get az direction with a negative sign. So if you solve this force, you are going to get it as integration 0 to infinite I, and this is going to be dy, and this is going to be, minus is going to be cancelled, and you will be getting e raised to the power minus y, and this is sin x, and you will be getting the direction as az. Now this is what you have to integrate for y. So this I e raised to the power, I sin x is going to come out, and integration 0 to infinity you can do for e raised to the power minus y dy, and the direction is going to be az cap. So if you solve this, current is going to be how much? Just put all the values. You will be getting the force as 5 sin x, and the direction is going to be, as per my reference, it is az, and this is Newton. But he is asking force density. How you are going to find the force density? Force density you are going to find as force divided by the area. So what is the area? Area is already mentioned here. This is going to be your area. So divide this force by this area and you will get your answer. I think you must be getting force density as sin x, this is az, and this is divided by the cross section area, that is going to be 5 into 10 to the power minus 6. So if you solve this, you will be getting 10 to the power 6 sin x, 10 to the power 6 sin x az. This is going to be your force density. Everybody just tell me in the comment section, is it clear for everybody? Yes, everyone. See the next question. The next question talks about the coil of 300 tons wound on a non-magnetic core having a mean circumference. Mean circumference, that is the length of the core, is given as 300 millimeters. So this is 10 to the power minus 3 meter. The cross-sectional area is given as 300, it is millimeter square, so 10 to the power minus 6 meters. He is asking the inductance of the coil corresponding to a magnetizing current of 3 ampere. So current I is also given as 3 ampere, So how you can write the inductance? This is going to be mu naught N square A upon L. Number of turns are given as 300. L core length is given as 300 10 to the power minus 6, and the mean circumference of the core is given as 300 10 to the power minus 3. Just solve this value, you will be getting the inductance. I think it is coming as 113.04. B is going to be the correct option. Is it clear? Every year they are asking very similar question about the magnetic circuits or the inductance, capacitance. So you can very easily judge what type of questions they are going to ask, and better you channelize your preparation only in that direction as far as GATE is concerned. See the next question. He is saying the flux density at a point in the space is given by this expression, and he is asking what is going to be the value of K. Now you know that for a magnetic field we have the Maxwell equation which says that the divergence of magnetic field density is always zero. Is always zero. What are the consequences of this? Number one, monopoles do not exist. Monopoles do not exist. Number two, total magnetic flux linked with a closed surface is always zero. In short, you define as the magnetic field as solenoidal, or you can say rotational, and this expression of the Maxwell equation says that the divergence of magnetic field is zero. Divergence of magnetic field is zero. Is it clear for everybody? So this is the condition you have to apply on the given expression, and very easily you can find the value of the unknown. You have to write del dot B, which is del Bx upon del x plus del By upon del y plus del Bz upon del z is equal to 0. So you have to differentiate the x, y and z component with respect to x, y and z respectively, and you have to put it to 0. So if you differentiate 4x with respect to x, you will be getting 4. If you differentiate 2ky with respect to y, you will get 2k. If you differentiate 8 with respect to z, it is going to be 0. Very easily you can write k is going to be minus 2. Is it clear for everybody? A is going to be the correct option. Yes, everybody. At least say yes or no in the comment section. See, the next question is also based on the similar logic. He is saying the following 4 vector fields are given in the Cartesian coordinate system. The vector field which does not satisfy the property of magnetic field, magnetic flux density, is going to be. So basically you have to check for all the options whether del dot B is 0 or not. So if you see, y square differentiate with respect to x 0, z square differentiate with respect to y 0, x square differentiate with respect to z is 0. It means del dot B is going to apply here. B option, z square differentiate with respect to x 0, x square differentiate with respect to y 0, y square differentiate with respect to z 0, Again it is going to applying here also. X square differentiate with respect to x, yes, it is going to be 2x. Differentiate y square with respect to y, 2y. Differentiate z square, this is going to be 2z. Now this is not going to be 0. It may be 0 for some particular points, but it is not going to be 0 for all the cases. Whereas we say for the magnetic field del dot B, that is the divergence of magnetic field density B, is going to be 0 always. So this has to be 0, which is not the case. So C is going to be the correct option. You can check for D option also. Y square z square differentiate with respect to x0, x square z square differentiate with respect to y0, x square y square differentiate with respect to z. This is also 0. So here also it is going to apply. See, the next question is saying the flux linkage lambda and the current I in relation in an electromagnetic system is given as lambda. He is giving as under root I upon G, or you can write I is equal to lambda square G square, and he is saying current is given as 2 ampere, air gap length is given as 10 centimeter. He is saying the magnitude of the mechanical force on the moving part in newtons. You understand how you are going to calculate when you are dealing with the magnetic circuits, how you are going to calculate the force. The first thing you have to do is you have to find the energy stored in the field, and that energy stored in the field you have to differentiate with respect to the movement, that is the air gap increasing or decreasing. That is how you are able to find the force. Yes or no? How you are going to first find the energy stored in the field? Energy stored in the field you are going to find as integration of I as a function of lambda and d lambda. If you differentiate it, I you can write as lambda square G square, and this is going to be d lambda. Okay, and if you solve this, it is going to be G square lambda cube upon 3. If this is the energy stored, now you can find the force. Force is going to be dE upon dG, because G is the air gap length. If you differentiate with respect to G, this is going to be 2 times G, this is going to be lambda cube, and this is going to be 3. Now if you see the question, he is giving you the current and he is giving you the air gap length. So we have to put the value of lambda. What is going to be the value of lambda? The value of lambda is here. It is under root I upon G. So this is going to be 2G upon 3, and lambda is given as under root I upon G, and this is cube. Just put all the values, solve it. You will be getting the force. As for my reference, you must be getting as 188.56. The force you must be getting as 188.56 Newton meter. Is it clear for everybody? Tell me in the comment section, are you getting this? So this is all from my side for today. Thank you so much for joining me live in the discussion. I hope you have enjoyed the session and you have learned something. Stay connected. So we are coming with more and more sessions which are going to be important to you for the upcoming examination. Thank you so much. Take care of yourself and stay connected. Thank you so much, everybody. Take care. Thank you everybody.